nobody was ready for what came back. When James Webb Space Telescope locked its golden mirror onto Pluto for the first time, the scientists on the receiving end of that data were not looking at a picture. They were looking at a confession. A chemical signature so dense, so unexpected, and so deeply strange that several of the researchers involved have since described the experience in terms that sound less like science and more like dread. This is not a story about a dwarf planet getting a closer look. This is a story about a world that spent 90 years pretending to be dead, and what happened when the most powerful eye in human history finally caught it in the act. What Webb found at the edge of the solar system should change how you think about everything beyond Neptune. And if it doesn't unsettle you, you are not paying close enough attention. To understand why the Webb observations hit the way they did, you have to understand what Pluto was supposed to be. For the first 75 years after Clyde Tombaugh spotted it blinking against a photographic plate in 1930, Pluto was essentially a rumor. Too small to resolve, too far to reach, too dim to read. It was a smudge with a name. Scientists guessed it was cold. They guessed it was icy. They guessed its tilted, stretched orbit meant it had a violent origin story. Beyond that, they were filling in blanks with pencil, not ink. Then, in 2015, the New Horizons spacecraft arrived after 9.5 years of travel and turned every single one of those guesses inside out. The surface was not barren. It was not featureless. It had mountains of water ice harder than granite, plains of nitrogen ice that churned and self-renewed, a sweeping heart-shaped basin 1,000 miles across, and a thin blue atmosphere layered with hydrocarbon haze. Pluto looked, impossibly, like it was alive. But New Horizons was a flyby. It screamed past at over 30,000 miles per hour, grabbed everything it could in a single pass lasting minutes, and kept going. Everything scientists wanted to know that they didn't catch in those few moments, they would never catch again from that probe. The spacecraft was already accelerating away before the data had even finished transmitting. The flyby gave us a portrait. What was needed was a forensic examination. That is what Webb was built to do. Webb doesn't photograph. It reads. Every molecule in every atmosphere around every planet absorbs and emits light at specific fingerprint-precise wavelengths. Webb's instruments, particularly its near-infrared spectrograph and its mid-infrared instrument, known as eerie, are designed to detect those wavelengths with a sensitivity that no telescope in the history of astronomy has ever approached. It doesn't matter that Pluto is 3 to 5 billion miles away. It doesn't matter that Pluto reflects only a pale sliver of already faint sunlight back across that distance. Webb can catch that sliver and dissect it down to the molecular level. In late 2022, it began doing exactly that, and the results, published progressively through 2023, 2024, and into 2025, have made Pluto stranger with every new data release. The first thing Webb confirmed, really confirmed, with a precision no instrument had ever managed, was the chemistry of Pluto's surface. Carbon dioxide, carbon monoxide, methane, water ice, ethane. These were not entirely surprises. New Horizons had detected several of them. But Webb resolved them at a spatial and spectral resolution that exposed something that had been hiding in plain sight. The distribution of these compounds is not random. It is structured. The carbon monoxide is concentrated inside Sputnik Planitia, the western lobe of the Great Heart, in a way that speaks to active atmospheric cycling. The methane is layered over different terrain types at different thicknesses. The ethane is distributed in a pattern that traces the flow of chemistry downward from the upper atmosphere to the surface. What Webb is reading is not a static snapshot. It is the output of a machine that has been running continuously for 4 billion years. The machine works like this. Sunlight reaches Pluto at about 1,000th the intensity it reaches Earth. Standing on Pluto's surface at noon, you would see the sun as a brilliant, tiny point, brighter than any star, but casting almost no warmth, no glare, nothing that your skin could register as heat. That faint trickle of ultraviolet light hits methane molecules drifting in the upper atmosphere and tears them apart at the molecular bond. The fragments don't escape. They recombine. Ethane forms. Acetylene forms. Ethylene forms. Progressively heavier and more complex hydrocarbons accumulate, then clump, then fall, settling towards the surface in a slow organic rain that has been falling since the solar system was young. The particles that don't evaporate back become tholins, reddish-brown, nitrogen-rich organic molecules that coat the surface like a chemical memory. Tholins are not exotic. They are the same class of compound that existed in Earth's early atmosphere. They are considered one of the precursor ingredients for the kind of prebiotic chemistry that may have eventually led to life. On Pluto, they have been accumulating for billions of years in a cold so absolute that nothing can act on them. The chemistry of life, frozen mid-sentence, preserved in a dark that never breaks. The temperature on Pluto's surface sits between roughly minus 380 and minus 369 degrees Fahrenheit. To put that number into any kind of experiential frame, consider this. The coldest temperature ever recorded on Earth at a Russian research station in Antarctica was minus 128 degrees Fahrenheit. Pluto is more than 250 degrees colder than the worst cold this planet has ever produced. At those temperatures, the nitrogen that makes up 78% of Earth's atmosphere does not exist as a gas. It exists as snow. It falls. It settles. It forms glaciers. The air you are breathing right now would crystallize on Pluto's surface into a thin white frost and sit there, frozen solid, until the sun's faint warmth, 2.5 centuries later, nudged it back into a gas for a few brief decades before it froze again. Pluto breathes on a 248-year cycle, and we happen to be watching it exhale. The second major Webb finding is the one that escalates this from strange to genuinely disturbing. Pluto is bleeding. Methane molecules, light enough and energetic enough to drift upward through Pluto's weak gravitational grip, are escaping the atmosphere and drifting into space. This was suspected before Webb. What was not known, or rather what was suspected but never confirmed with real evidence, was what happened to the escaped material. It turns out the answer is that it doesn't disappear. It gets stolen. Charon, Pluto's massive companion moon, sitting roughly 12,000 miles away, is catching it. Charon is not a small, forgettable rock. It is about 750 miles across, making Pluto and Charon one of the most closely matched planet-moon pairs in the solar system. The two bodies don't orbit each other the way Earth and its moon do. They orbit a shared gravitational center point that sits in empty space between them, locked face to face, tidally frozen, each world always showing the same face to the other across that 12,000-mile gap. From Pluto's surface, Charon would hang in the sky and never move, never rise, never set, just fixed overhead, gray and vast, a watching presence that never blinks. From Charon, Pluto would do the same. Two frozen faces, always staring, exchanging matter in perfect silence. What they are exchanging is now confirmed. Webb's observations, combined with results published in a landmark 2024 paper, established definitively that Charon's polar red stains, those strange reddish-brown caps that had puzzled scientists for decades, are built from Pluto's stolen breath. Methane escaping Pluto drifts across the void, gets trapped by Charon's gravity, freezes onto its poles and then gets broken apart by solar radiation and cosmic rays into heavier organic compounds. The same Tholin chemistry being performed in Pluto's own atmosphere is being performed on Charon using material siphoned directly out of Pluto's air. It has been happening for billions of years. Pluto is painting its moon with its own atmosphere, one molecule at a time, and the painting is the color of rust. Webb also confirmed the presence of carbon dioxide and hydrogen peroxide on Charon's surface. Carbon dioxide is what you exhale. Hydrogen peroxide is what you would pour on an infected wound. Both are sitting frozen on a moon in the outer solar system, manufactured by high-energy radiation rearranging the atoms of Charon's water ice into new compounds. The radiation doesn't care that the chemistry is strange. It just keeps breaking bonds and the matter keeps rearranging itself into new forms, driven by nothing more than the faint wind of particles blowing from the sun at that enormous distance. Chemistry without a chemist. Reactions without an intention. And yet the products are real, sitting there on the surface of a moon no human being has ever visited or ever come close to visiting. Then Webb looked at the atmosphere. Not just what was in it, but what the haze was doing to the planet it was wrapped around. A team, led by Tanguy Bertrand, used Webb's mid-infrared instrument to confirm something that had been proposed theoretically years earlier, and seemed, at the time of its proposal, almost too strange to be real. Pluto's atmospheric haze, those dozens of thin, layered hazes of complex hydrocarbons floating in the thin atmosphere above the surface, is not warming the planet the way hazes warm other worlds. It is cooling it. The haze particles absorb incoming sunlight and then radiate that energy back out in the mid-infrared, dumping heat into space faster than the atmosphere can hold it. Pluto is being actively chilled by its own sky. The atmosphere is a refrigeration system, and it is working. Nothing else in the solar system has an atmosphere that behaves this way. Not Titan, not Triton, not any other icy body we have studied closely. Pluto is thermally self-regulating itself into a deeper cold than the distance from the sun alone would produce, and the mechanism doing it is the same haze that falls as organic chemistry onto the surface below. The thing that is killing Pluto's warmth is the same thing building its surface. It is bleeding heat and building itself simultaneously on two different timescales, with the same particles doing both jobs at once. Webb's observations also returned something about the surface composition that planetary scientists are still working to fully model. The ethane distribution Webb resolved, with more precision than any previous measurement, does not match what existing atmospheric chemistry models predicted. There is more ethane in certain surface regions than the models produce. Either the models are missing a chemical pathway, or something on the surface is participating in the chemistry in a way that hasn't been accounted for. Several researchers have proposed that subsurface processes could be involved. That word, subsurface, carries enormous weight when you say it about Pluto. The possibility of a subsurface ocean on Pluto is not speculation anymore. It sits in a gray zone between hypothesis and emerging consensus, and the evidence keeps accumulating on one side of that line. The argument begins with Sputnik Planitia, the western lobe of the heart. It sits in a gravitational anomaly. The region has a positive mass anomaly that points to something dense underneath it. Liquid water, denser than the surrounding ice, fits the mathematics. The crack and ridge patterns on the surface near the edges of the heart are consistent with tectonic stress from a freezing ocean interior, the same kind of patterns that betray Europa's hidden ocean beneath its icy shell. Pluto's core is rocky. Rocky cores contain radioactive elements. Radioactive elements decay slowly and release heat. That heat, spread over 4 billion years, could very plausibly be enough to maintain a liquid layer somewhere between 100 and 180 miles beneath the surface. The ice above it is not ordinary ice. At those pressures and temperatures, It would be a form of ice that is a poor conductor of heat, an insulator that holds whatever warmth exists beneath it far longer than ordinary ice would. If that ocean exists, and the evidence, while not yet conclusive, is no longer thin, it has been liquid for billions of years. It is dark. It is cold by Earth standards but warm by Pluto's. It is under pressure. It is almost certainly salty, and it is receiving, through cracks and permeation, some portion of the organic chemistry that has been raining from the surface for billions of years. Tholins dissolving into a deep brine, hydrocarbons seeping down through ice. A chemistry happening in the dark, at depth, without sunlight, without any of the conditions we typically associate with the possibility of life, and yet fitting the basic recipe of liquid water, plus organic chemistry, plus a long time that has produced life exactly once, here, on the only world where we have ever confirmed it. We know that recipe works. We don't know that it only works once, or only in one place, or only with sunlight as the energy driver. We don't know that at all. What Webb has given us is the most detailed chemical portrait of Pluto ever assembled. It has resolved molecules that New Horizons could only hint at. It has confirmed processes that theoretical models had predicted, but that observations had never supported at the required precision. And it has done something more unsettling than either of those things. It has revealed that Pluto is not a frozen accident at the edge of the solar system. It is an active participant in the chemistry of the solar system, doing things that matter, producing compounds that matter, cycling matter between atmosphere and surface and moon on timescales that dwarf every civilization that has ever existed on Earth. It has been running its slow chemistry experiment since before complex life evolved here. It will still be running it long after the sun has swelled and consumed everything we have ever known. And Pluto is not alone. The Kuiper Belt contains hundreds of thousands of objects larger than 60 miles across. Beyond it, the scattered disk extends further still. Beyond that, the Oort cloud, a shell of icy bodies thought to stretch a quarter of the way to the nearest star, holds 1 trillion more. If Pluto is doing all of this with its faint sliver of sunlight and its weak gravity and its thin atmosphere, what are the others doing? Eris, Makemake, Sedna, Quaoar, the larger bodies Webb has already begun to observe, all have their own surface chemistries, their own atmospheric histories, their own geological puzzles. The smaller ones, the hundreds of thousands we cannot resolve at all, are nearly invisible, but they are not nothing. They are frozen repositories of the same prebiotic chemistry that Pluto is running, most of them untouched since the solar system formed, sealed in cold so extreme that the organic molecules inside them have had 4.5 billion years to sit undisturbed. Whatever chemistry began in them during formation is still in there, waiting, frozen mid-step, like everything else out there. The haunting thing is not what Webb found. The haunting thing is the scale of what Webb has begun to suggest. We have one good example, one well-studied world at the edge of everything, and it turns out to be doing something extraordinary. It turns out to be thermally active and chemically dynamic and atmospherically complex and gravitationally intimate with a companion it has been slowly painting for billions of years. It turns out to possibly hide a liquid ocean under a shell of stone-hard ice. It turns out to be making the molecules of life in a place where life, as far as we can tell, cannot possibly exist. One world, one example out of trillions. And it is this: the question that should sit with you, the question that sits with every planetary scientist who works with this data, is simple and enormous, and has no answer yet. If the edge of the solar system is this alive, this chemically busy, this structurally strange, on a world we spent 70 years calling a frozen nothing, what else is out there? What are the worlds we cannot see doing in the dark right now? The organic chemistry raining onto Pluto's surface has been falling for 4 billion years, and we only just found it. The ocean that may sit beneath its shell has been liquid for geological ages, and we can only infer it from gravitational mathematics. The atmospheric cooling mechanism was running the entire time New Horizons flew past, and nobody knew to look for it. Pluto hid everything from us until the right instrument arrived. The right instrument is Webb, and it has barely started. There are a trillion other worlds out there doing their version of this, in silence and in cold and in the dark, and we have not looked at a single one of them the way Webb is looking at Pluto. Not one. The solar system we thought we understood, the neat diagram with the sun in the middle, and the rocky planets and the gas giants and the quiet, icy wasteland at the edge, that diagram was always wrong. It was a sketch drawn by someone who hadn't gone outside yet. Webb is going outside, and what it is finding in the first few steps is already enough to rewrite everything. Pluto is horrifying not because it is dangerous or violent or threatening in any way we could ever directly feel. It is horrifying because of what it implies. It is horrifying because of the silence and the scale and the patience of it. A world doing extraordinary things in the dark for billions of years with nobody watching. And the moment we finally look, we discover that we have barely begun to understand what looking even means. There are 4 billion years of chemistry sitting on that surface, and we are only now reading the first sentence. There is possibly an ocean down there that has been liquid since before the first animal breathed on Earth, and we cannot reach it, and we don't know what is in it, and we may not know for a very long time. That is what the most powerful telescope ever built found at the edge of our solar system. Not emptiness. Not silence. A world alive with process and time and chemistry and mystery, so far away that the light it reflects takes hours to reach us, and so strange that every new look at it produces new questions faster than it answers old ones. Pluto was never a postscript. It was always a door. Webb just put its hand on the handle. What is on the other side, what is waiting in the trillion frozen worlds beyond it, is the question that will define the next century of space science. And I want to know if it keeps you up at night the way it keeps me up. Because if it does, you are not alone. And if it doesn't yet, it will. Give it time. Webb still has more to say.